Hello and good day. We are covering PO10 in Algebra. Yesterday we focused on combining like terms and the distributive property. 7 to practice with for that, and then we'll move on to variables on both sides. So the first 3 that I had you do were all with the combining like terms method. So what you're looking for here is, what terms have either the same variable, okay, or are constants. In this first equation, we had -4 and -6, both having an x. So we can rewrite this to be -20 equals -10x, is -4 minus 6. We're not using opposite operations. That's kind of the most common mistake that I see with this type. And we're not using them because we're not moving anything from one side of the equation to the other, right? That left side doesn't change, okay? So we just do the operations as they are written. In any event, divide both sides by -10, and we get an answer of x equals 2. Next one, after you combine like terms, you get 6 equals -2n plus 6. Subtract 6 from both sides. You get 0 equals -2n. And occasionally, I'll get the answer where it's no solution because you get that 0 there. But if you complete the process and you divide by -2, you can, in fact, divide 0 by -2. You just get 0. So 0 is our value for n. Then where do we go next? Second row, third one. We've got 24 equals 8p minus 8 after combining 5p and 3p. Add 8 to both sides. Divide by 8, and we get an answer of 4. Issues so far? Soybean.
For the second one on the top row, I did 6 equals 6 minus 2.
You should have gotten the same answer, right? Because Soybean says that he wrote his as 6 minus 2n. As we've seen in the 5-card challenge in the math packets, those two equations are the same because both of them have a positive 6 and a -2n. The order doesn't really make a difference. So Soybean, you would still subtract 6 from both sides to get 0 equals -2n, and then from there, calibration. And then from there, you'd still divide by -2 and get 0. So the order that's written in doesn't matter. Anything else? Okay, very well. A little further on down the page. Too far down the page. Okay. 5p minus, nope, where are we? The parentheses. Okay. -8 equals 10 minus, then parentheses, x plus 4. The negative sign is what gets distributed in, or more correctly, a -1. Okay. So we get -8 equals 10 minus x minus 4. All that really does is it changes the sign of each term inside of your parentheses. Combine like terms, 10 and -4. We get -8 equals -x plus 6. Make sure you watch your sign there. Subtract 6 from both sides. We get -14 equals -x. But we're not done yet because what is the coefficient to x? It's that sneaky, Evan? That sneaky -1. So our last step would be to divide by -1, which really just changes the sign. And so x equals 14 should be your final answer. Okay. Next row, distribute in the -4. So we get 20 equals -64x minus 12. -4 times 16, -64. -4 times 3, -12. Add 12 to both sides. 32 equals -64x. Divide both sides by -64. And we get -1/2 or -0.5 as our value for x. Next one, distribute the 6. 12 equals 6p minus 48. Add 48 to both sides. 60 equals 6 times p, divide by 6, and we get a value of 10. And the last one in this row, distribute -4. So we get -28 plus 20x equals 12. Check those signs. Okay, negative 28, positive 20x. Add 28 to both sides. We get 20x equals 40. Divide both sides by 20, and our variable is 2. Was that the last one I had you do? Okay, I thought I gave you 7, only 6. Okay. Was that 7? Oof, I'm ready for MEA. Yes, Bridget. For which one? Did you get this part correct? Did you have a positive 28 by chance?
No, I did a minus. So negative 28 and minus 28.
Oh, okay. Okay. Yeah, and the reason why it's a positive, just to reiterate, we've got a negative 4 here and a negative 5x. That sign belongs to it, so a negative times a negative would give you that positive 20x. Yes, Lucas.
For the one that ends in -1/2, is it okay if you write that in decimal form?
It is. Yep. Anything else? Okay, very good. Variables on both sides. Let's go back a bit to the second page. Yeah, the top of the second page of PO10 here, variables on both sides. And my understanding is you've had experience with these as well, yes? Okay. No? Some of you maybe more than others? Okay. All right. Okay. Word doesn't like the fact that I put an extra space in front of that equal sign there. It's going to drive me nuts if I don't fix it. Let's see. Some in-class editing here. There we go. We'll save that. Now life is good. Okay. So tell me how we work with, how we handle an equation with variables on both sides. What are we looking to do, and how do we do it? Gabby. Right. We're still looking to get that two-step equation. And so our goal is to move all variables to one side. And I'll add on here to get two-step equation. All of these had the end result of getting that two-step equation, right? But in this case, we want to get all of our variables on one side. And this can be a little bit tricky because normally when we deal with a term involving a coefficient and a variable in solving an equation, what are we doing? Elise?
Are we doing the opposite operation on constant?
Of the coefficient, you mean? Or okay, yeah. So normally, what I'm trying to ask here is like normally when you see a variable term in solving an equation, you got something similar to that, right? And what do we do in this case? How do we handle this? Yeah. Divide by 10. Because in this case, we want to break apart the variable from the coefficient, right? We don't want x to move. We want to divide by 10 so this cancels out and x is by itself. Okay? So I think what Elise was saying here is that we're still using opposite operations in this case, but not with multiplication and division. Because in this instance, we want to move all of these x's over to the other side, all 16 of them. Okay? So one option that we have, I'm going to write this twice here, so bear with me while I... One option that we have, if we choose to move our variables to the right, is we're going to subtract 16 x's. Okay? Sometimes people want to divide by 16 here because they're so used to dividing when you see that variable term, but we're moving the x along with it. All 16 x's are being moved over to the right side. And so we're subtracting, because 16x's minus 16 gives us 0. Don't forget about the sign of that 5. It's a negative 5. And then that equals 12 minus 16 is negative 4x plus 23. There we have our two-step equation. Yeah?
Is it okay if first we add 5 and then we subtract 12?
Yeah, Daniel's asking, is it okay if we move our constant over first? Yes, it is. Yeah, and that's a very, very good point. So Daniel's a positive person, right? Doesn't like to dwell in negativity. And so he's saying that he likes to deal with positive terms. And I think that's probably true for most of us. If we can avoid the negative sign, let's avoid the negative sign. So another option that you have is instead of moving those 16x's over to the right side, you can move the 12x's over to the left side. Okay? And what that's going to do, this time we're subtracting 12x from both sides. So they cancel out on the right side. 12 minus 12 gives us 0. And now we have positive 4x minus 5 equals 23. So the only difference between the two equations that we have here is which side of the equal sign we moved the x's to. We moved them to the right side, we get negative 4x. We moved them to the left side, we get a positive 4x. We will get the same value when all is said and done, though. Bridget.
What happens to the x with like the other 16, the one that you cancel out? What happens to that x?
Those x's all move over to the other side, right? By subtracting 16x's, I'm taking, let's say that x equals markers, right? I've got 16 markers here. I'm taking all 16 of them and I'm bringing them over to the other side. So the x is moving over, okay? Which is why we're adding and subtracting rather than multiplying and dividing. So just to prove a point, let's finish this out here. We have a two-step equation. Subtract 23 from both sides. Negative 28 equals negative 4x. Divide both sides by our coefficient, negative 4. Now we're dividing, right? Because now we want to split the coefficient and the variable apart. We want the x to stay on the right side, but get rid of the negative 4. So dividing by negative 4, that gives us a value of 7 for x. Keeping the variable term positive, adding 5 to both sides, we get positive 4x equals positive 28 divided by 4, we still get positive 7. So it does not matter which side you move the x's or the n's or whatever, your variables to, okay? You will get the same result, all right? Sometimes folks like to think about this in terms of like a basketball score. If the score of your game is 16-12, right? You've got 16, your opponent's got 12. Isn't that the same as being ahead 4-0, really? Because how many points you have doesn't really matter. It just matters that you've got more than the other team, right? So if you recognize that hey, this left side of the equation has 4 more x's over here. This side of the equation has 4 more x's. I can just write that. I can rewrite this rather than 16x on the left and 12x on the right, just put 4 on the left, none on the right, 4-0, and solve it that way. Okay? That might take a minute for you to wrap your head around, but if you're able to do that, it kind of allows you to do one of those steps more mentally. Okay? Questions so far? Okay. Looking at that second one, I want to try the comparing method first here. You've got negative 8 n's. Remember that coefficient tells you how many you have. You have negative 8 n's on the left, negative 5 n's on the right. Which side has more n's? Which side has more n's, Gabby? The right side, because negative 5 is greater than negative 8, right? How many more are on the right side? How much greater is negative 5 than negative 8? Elise? 3. So it would be okay to say, okay, I've got 3 more n's on the right side. I'm just going to rewrite this to be 9 equals positive 3n minus 18. Because I've got 3 more on the right side. Right? Mathematically, what we're doing here is we're adding 8n to both sides to actually cancel them out from the left. And negative 5 plus 8 is positive 3. But mentally, you can kind of think about that as negative 5 is 3 more than negative 8. So I've got 3 more on the right side, 0, and positive 3. that make sense? Kind of? You see where I'm going with that? Or you've got the kind of the process way there, add 8n to both sides. Either way, two-step equation, add 18, 27 equals 3n, divide by 3, and we get 9. Okay? The next two are kind of special in how they're set up here. What's different about, let's start with the third one there. What's different about that third one than the first two? Yeah, Quinn.
There's 9y on both sides, both positive, so if you minus 9y on one side, it would just be nothing.
Couldn't have said it better myself. What Quinn says is that there's the same number of y's on both sides of the equal sign, right? So that when you subtract 9y from one side to cancel it out, what happens to the 9y on the other side? It also cancels out, right? I want to move my variables over to the right side, but they end up both canceling out, okay? The reason why that is because whatever number you plug in for y, if you multiply that number by 9, you're going to get the same result, right? If y is 8, 9 times 8 is 72 on both sides. If y is 4, 9 times 4 is 36. So what you're left with is this equation, negative 12 equals 18. Is that true? No. So, when growing up, your teachers would always say, there's always an answer. There's always a solution. Not always, right? What this means is that there's no possible value for y that's going to make this equation true. Because whatever number you plug in, whatever 9y is, on one side you're subtracting 12, and on the other side you're adding 18. You'll never get those two sides to balance. So, there is no solution. Okay? The symbol for that is a 0 with a line through it. No solution. The fourth one, we kind of run into the same situation here, right? Yeah.
There's 8n on both sides too, but if you were to minus 8n to go positive, it would equal 0 again, but it's still equal out to 7 equals 7.
Yeah, so this is similar in that we have the same number of variables on both sides, which means that they are going to cancel out. Okay? And then on the left side, we have 2 plus 5, which equals 7. On the right side, we have 7. Does 7 equal 7?
Yes.
Yes, it does. So what does this mean? Lauren?
If there's any solution.
Any number that you plug in for n is going to work. Because on both sides, you're multiplying it by 8 and then adding 7. No matter what you plug in for n, you'll always get the same result on both sides. So this is infinite solutions. And the symbol for that are all real numbers. Start with kind of like an 11. And then from the left segment here, we're going to come and kind of make an R with the one on the right. That's the math symbol for all real numbers or infinite solutions. It is kind of cool, isn't it? I actually have that tattooed on my thigh. Yeah. That's first of one. The other tat I have is I've got pi wrapped around pretty much my entire body. You can't see it because, I'm cold, but yeah. So if you ever see me in shorts, then there you go. Okay. Any questions on that?
That's a sin.
What is?
Why?
What? It was a joke, though. So that's different.
I know.
It's called sarcasm.
It's a joke.
You won't get any of it.
Okay. Let's practice some more here. Skip this next section for now, and let's come down to this page. Let's look at the third one in the first row, the one that we skipped over initially. 8x minus 2 equals negative 9 plus 7x. Yes?
Back to like the first page, I guess.
Yes.
But when we start like on the right side, the left side, do we always start on that side when we take like the number like minus? And
The The beauty of this is that you can kind of take any approach that you want to. Okay? If you want to move your 8x's over to the right side and start by subtracting 8x, you can. If you want to move your 7x's over to the left side and start by subtracting 7x, you can.
So you can just do it
Any way you want to. Most students I have found prefer to keep that coefficient to x positive. So most students will look at the first one here that we're doing together, and they'll say, I've got 8x's on the left, 7x's on the right. If I subtract 7x's to move them over, that's going to keep me with a positive x on the left side. Okay? Versus if you subtract 8x's, then you'll have a negative 1x on the right side. You'll still get the same answer, but most folks prefer to keep that coefficient positive. And this actually works out well to where it's a one-step equation. Add 2 to both sides, and we get negative 7. Okay? And for those that are trying to wrap their head around that mental first step, compare 8x's to 7. The left side has 1 more, and that's why we have 1x minus 2 equals negative 9, 1 to 0. Okay. Let's look at the one in the second row. First one, second row. A plus 5 equals negative 5a plus 17. Which side has more a's and how many more? Left or right? Which side has more a's and how many more? Soybe?
5 and A has 1.
Yes, right. That's a negative 5, right? So positive a, which really is a positive 1a, the left side has more. How much greater is positive 1 than negative 5? 6. So 6 more on the left. We can just go ahead and write 6a plus 5 equals 17, because 1 to negative 5 is the same thing as 6 to 0. Okay? Mathematically, what we did here was we added 5a to both sides. Negative 5a plus 5a is 0, and 1 plus 5a is 6a. Daniel,
Do you want to still show our work?
I would like you to show your work, yes.
Like,
If you want to do that first step mentally, you can, just to practice it. But if you're doing it the mathematical way, then you need to show your work. I mean, it's all mathematical, I guess. But yes, and check your answer as well. All right. So now we're at a two-step equation. Subtract 5. 6a equals 12. Divide by 6. A equals 2. Okay. How do you check something like this when you have variables on both sides? Well, similar to how you would check it if you didn't have variables on both sides. You take that value for the variable, in this case 2, and plug it in. Does 2 plus 5 equal negative 5 times 2 plus 17? It does, right? 2 plus 5 is 7. Negative 10 plus 17 is also 7. Okay. Tell me about the next one. What's special about that one? And how are we going to handle it? New voices today, maybe. Someone waiting to be the next YouTube star.
Oh.
No? Soybe?
They're both 4.
Yeah, so what can we do with the 4m's? Yeah.
You could cross both of them.
Cancel them out, right? 4m will be the same thing. If we subtract 4m from both sides, we get 0m on both sides. So we're left with negative 4 equals 0. Is that true?
Yes.
No. Ugh.
no.
So it's no solution. Okay. All right. What's that? How do you check that? That one is really uncheckable. The only way to check it would be to defend it and say that, well, if I plug in a value for m, whatever I pick, it's not going to work out, right? Because 4m will be the same thing on both sides. On one side, I'm subtracting 4. The other side, I'm not doing anything. Okay. Let's go to the next page. I feel like if math were like the Mushroom Kingdom, then these equations would be the Bowser. I just get that sense. Okay. There's another page. Take a look at what we have here. Right? Yes. Yes. Oh boy. Pick one from the first two rows here that you'd like to do together. You have 5 days off. Do not whine. Well, not right now, but yeah, 5 days off away from school. I don't think that's the rule. I mean, we could complain about it or we could work on it. I mean, I don't know. Choice is yours. Pick one you like to do. Yes, Elise. Sure. Okay. 3n minus 5 equals -8, and then parentheses 6 plus 5n. So here's the deal where, we talked about the 3 different types of multi-step, combining like terms, distributive property, variables on both sides. Now we're combining those. So it's like a multi-step. Okay. I see that I've got parentheses, so I know I'm going to have to distribute. And then I see I've got n's on both sides of my equation. So I'm going to have to deal with both of those situations. What do I do first? Yes. And we'll hold on. I'll tell you. There's a pretty simple way to check answers that we'll talk about once we do the last one, because I almost guarantee you'll pick that one to do next. But anyway, so we're going to distribute first, okay? Which means we're not doing anything to the left side here. 3n minus 5 equals -48 minus 40n. Okay? 3n minus 5 equals -48 minus 40n. And I got that by multiplying -8 by 6 and -8 by 5n. Now that I've done that, now I've just got a standard variable on both sides equation. Okay? In the interest of keeping my coefficient positive, I'm going to move my n's to the left side by adding 40n. -40 plus 40 is 0. 3 plus 40 is 43n minus 5 equals -48. Now I'm at my two-step equation. I'm comfortable. I'm going to add 5 to both sides. I've got 43n equals -43. Divide by that coefficient, and -43 divided by 43 is -1. Okay. Now for checking this, you are able to use a calculator, and there's no reason why you shouldn't use one here to quickly and easily check this. In your calculator, just put in -1 for n. 3 times -1 minus 5. You can either use the multiplication symbol or you can put -1 in parentheses. Just remember that your negative sign is actually down at the bottom of the calculator by the decimal point. It's not the subtraction symbol. Your negative sign on most of your calculators looks like this. It's like a negative in parentheses. So 3 parentheses, -1 parentheses, minus 5. Okay, that ends up being -8. So just kind of write that down, store it, remember it. And on the other side, again, just in your calculator, -8, 6 plus 5 times -1. Okay. And if you don't get -8, well, then you have to look back and see where you went wrong. But you do. So -8 equals -8. It should take you no more than 10 seconds, 15 seconds to check that, and it's worth it. Okay. Questions on that? Okay. One more. Let's just drop right down and do this one here. The 5 times parentheses -8x minus 2 equals -4x minus 8x plus 16. This is like the trifecta. I'm looking at it. I see parentheses. I see variables on both sides. And I see I'm going to have to combine like terms. Okay. So if you can do this one, you will be able to solve pretty much any linear equation that you come in contact with. All right. So let's start. Distribute first. 5 times negative 8 is a negative 40. 5 times negative 2 is negative 10. And just like that, I've dealt with those parentheses, right? Left side's done. On the right side, negative 4x minus 8x. What are those combined to equal? Bridget.
Combine 4 and 8.
You combine negative 4 and negative 8 to get negative 12. Very good. So in one line, one step, it was 2, but I've taken care of the parentheses and I've combined the like terms. Okay. Again, we're not using opposite operations here with that negative 4 and that negative 8 because I'm not moving them. They're still on the right side. I'm just combining them. Now, though, I am going to be moving terms. I can't avoid having a, oh, yes, I can. I can add 40x to both sides in the interest of keeping my coefficient positive. And I get negative 10 equals positive 28x plus 16. Ooh, Bowser, you scoundrel. This isn't going to end pretty for us, is it? No, it's not. That's okay, though. We can do it. Subtract 16 from both sides. We get negative 26 equals 28x. Yeah, well, could be worse. Not sure how, but could be. Divide both sides by 28. And rather than calculate that decimal or use that decimal, I mean, negative 26/28, yeah, it's not very pretty, but it's a fraction. Division is a fraction. So what does negative 26/28 simplify to be? Because your answer would need to be in simplest form. Negative 13/14. Negative 13/14 is the value for x. How would you check it? Right, exactly. This is why we have calculators. No one wants to try and solve this, showing the work for negative 13/14. So there are 3 options. That's 2. You have 3 options that you can use here. Okay. The first to check this is to literally just plug in negative 13/14 wherever you see an x. It becomes kind of a parenthesis nightmare. Your calculators. Do you know how to make fractions on your calculators other than using the division symbol? So do you see the ABC button? It looks like this. If you press that button, you get something. I forget which way it goes. Does it go like that or like that? The other way? Okay. So that's kind of the fraction bar button. So if in your calculator, you type this in 5 parenthesis negative 8, and you can even use the multiplication symbol here. And then negative 13, press that ABC button. Okay? And then subtract 2. Your other option, if you want to go this route, is to put 13/14 in parentheses with your division symbol. But it becomes kind of a parentheses nightmare there. There's a lot going on. The top one or the bottom one? So the ABC button. So press 13 or press negative 13. And then the ABC. And then 14. And that's the fraction negative 13/14. Okay? And then on the right side, you would do the same thing. Negative 4 times 13 ABC 14 minus 8 times 13 ABC 14 plus 16. And those 2 values should match. It's going to be a nasty decimal probably. But yeah, so the answer that you get, since you use this ABC button, your calculator gives you something like 27 U and then 1/7. Is that what it looks like? Yeah. So that U is the mixed number symbol. So what it means is that it's 27 and 1/7. Okay. It doesn't do that so that because if you see 27 and 1/7. That's how your calculator would write it. You might think it's 221 sevenths, which is not the same thing. So that U is kind of the mixed number thing there. Okay. We are running low on time. So the other option for checking this would be to get the decimal value and round it and plug that in. The danger with that, though, is that if you use the decimal value, you might, I'm just making this up, you might get something like 3.5 for the left and 3.46 for the right, and you might think that you're wrong, but why are those close enough for you to be confident that you did get the correct value for x if you're using a decimal rounded value? Kind of. It's more so that since you're using a rounded value, you're losing accuracy, right? And so these answers might not be the same as they would be if you use the fraction 13/14. They might not be the same, but they're close enough that with a rounded value, you can be confident that you were right. So your homework for Monday is to leave no question left unanswered on the PO10 Part 2 pages. No equation left unsolved. So starting here with PO10P2, you're doing everything. The first page is more or less done because we did most of it, in homework or in class together. But that second page, all equations on PO10 Part 2 due for Monday. Yes?
Like the second page of the homework, how would you do like the first one and the second half?
First one, second row with the two X's here.
No, like the page that we were just on.
The A plus 5?
No, like the next page.
This one?
Yeah.
Which?
How would you do like the ones in the bottom of the screen?
That one? Okay. So the question is how you would handle this one here. Okay. You've got two sets of parentheses, which means you're going to have to distribute 2 times. Right? This negative sign, really a -1, distribute into the parentheses here, and then take your -6 and distribute it into the parentheses there. Once you do that, the parentheses will be gone, but you have some like terms that you can combine. And then you go that route. But yeah, so you got 2 sets of parentheses you need to distribute twice. Pay really close attention to signs on that one. Okay, and I've gone into overtime, so we'll wrap the video up here. Leave no equation unanswered as your homework for Monday. That is how you math.
Don't forget to